There are other ways to scale to achieve high availability than the mechanisms we've already discussed, which included horizontal and vertical scaling, and then geographical scaling within a public cloud. The first of these is really cool, and it's called cloud bursting. And the way that we implement this is, so let's assume that we have reached some sort of saturation or capacity limit in our on-prem data center. There's either no room to expand because there's no physical space, or maybe new servers have not been provisioned recently and we have no compute capacity to expand into. What can we do? Cloud bursting is where you actually scale by adding capacity in a public cloud infrastructure to take that overflow of work. Another really cool way of scaling is called oversubscription. This one's a little different than everything else we've talked about. Oversubscription is primarily done for cost efficiency reasons. And the way that you achieve it is by allowing virtual resources to be provisioned that when you add them all together, they actually equal more than the physical resources you have available, with the assumption that you're never going to end up being saturated. This is a fairly common implementation pattern, especially by public cloud providers, and can be implemented on CPU or processor, memory, and network throughput. Other ways of scaling are going to be for different requirements of what we've talked about other than just needing extra capacity. When scaling, if you want to prioritize hypervisor affinity, what does that mean? What you're trying to do is to place your resources as physically and as virtually close together as you can get without any sort of blocking or oversubscription. This is going to be for achieving high network throughput and low latency because they're that close. This is going to be when you have multiple resources and the majority of the traffic is between the nodes of that workflow. And it's not going to be designed for resilience. Let's say, for example, that all of your resources that exhibit hypervisor affinity end up on the same server or in the same rack. And then the provider has to perform some sort of maintenance, which includes powering down the entire rack. You would lose the entire cluster in that case. How can we address that? We can go the opposite direction and prioritize hypervisor anti-affinity. So rather than everything being clumped as close together as possible, each resource would be at the very least in a separate rack, if not separate data centers or even regions. This would be for critical instances that must be kept separate from each other and exhibit the highest availability that they can without an outage that affects one, affecting more than one. This is designed around the idea of guaranteed resilience, and, as I said, this could span multiple availability zones or even regions.